Okay, so hi, we are gonna see week 4 of, well, in this case, we're gonna talk about archaeological methods. So, okay, so we're gonna start with most important questions. 6 important questions of what we study in the what the archaeological methods study. So the methods for studying the past are based on 6 questions. Which are where, what, when, how, who, and why. Okay? And what those type of questions want to answer in each one of them is where, like survey and sampling. How we answer the question of what will be with archaeological recovery. When, relative and absolute dating. How, with a theoretical approach and environmental diet. Environments and diets. So it will be theoretical approach, environments and diets. Who? Burial context and osteological methods. Osteological methods. Why? Well, that's a big question. Okay, so we're gonna go to each one of them. So we start with where? Where? With people live. So what we need to answer this question would be first, archaeological sites. So we need that because in the archaeological sites we can find where people live and also what activities do they carry out on the past. So basically it's people live and activities. Then we have artifacts, mainly, of course, they're objects made by humans. And we have ecofacts, And what we see with the echo facts, it's that this means ecological debris, such as bones of other animals, and finally, last one of where, features. Okay? Non-portable remains. Graves or walls. Example, when someone died, of course, sometimes some features inside their tombs. Okay? Now, we had two type of different techniques for finding this and analyzing it. So, the first one will be morphological features. Sorry, no. The first one will be field survey. This is more like a note. Morphological features are sources of water, firewood, clay. Oh yeah, now I remember. And iron ore. So if we found this, we can analyze that, like any of these. So when we look at some of these things, we're gonna start with a field survey. And what's the field survey? Well, it's surface walking. And also subsurface investigations. Okay? So once we found something like this, or tried to look something, to found something, we can do anything of this, of the field survey, such as walk on space, let's say, yeah, mountains, I don't know, we walk, find those places. There are some type of, techniques or like machines or ways to analyze things that we found, or to look for things, also for locate spaces, such as, no, it's not to analyze, it's more to locate, because we are, survey. So in this case, some of the equipment for doing that will be electrical resistivity survey. We also have the proton magnet. It's magnetometry. Yeah, proton magnetometry. You also have the ground penetrating radar. Finally, random, going around, random testing. Okay, or also test heating. Okay, perfect. We also have, well, we better to erase. Samplings. Oh. Sampling. So here we use lab analysis. Okay? That what they do is to inform where to look and where not. Okay? So now, going to the next question. What are we going to answer with the question what would be what materials were left behind? Okay. So now we got the question what, trying to answer the question what materials were left behind. Okay. So through careful excavations, such as spatial contexts and associations, convenience, assemblage, drawings, photography. These are the type of things that are needed to be done when you do this type of excavations in archaeological zones. And then what we want to do is to, based on these things that we found and everything, to actually say when did all these activity humans occur And for answer that, we use that, what we found. So the question will be when the humans activities occur. Okay? So for that there are two types of methods. The relative dating methods and the absolute dating methods. So, for the relative dating methods, we have 4 different types of methods. Which are stratigraphy, seriation, self-dating, such as coins, coins, and cross-dating. For example, let's say, I don't know, they found a football ball, like football, soccer ball. So, or I don't know, basketball ball. Yes. Yeah. So let's say that this needed to be like the activity or what happened will need to be after the creation of the sport, because it doesn't exist before. So at least it needs to be starting on the time from where this was origin from. Okay. And then we have the absolute dating methods. So these ones, we also have 4 different types. First one is dendro chronology, radiocarbon, C14, if you remember, potassium, argon, KAR, and the OSL, which means optically stimulated luminescence. Okay? Yep. Now, it's also important to know different concepts of dates in the distant past. So let's go with it. Yeah. So we have dates in the distant past. Okay? So we have list AD. Anno Domini, BC, before Christ, BCE, before Common Era, then we got CE in the Common Era, BP before the present, that will be before 1950 AD. Okay. Here we got GA, or years ago. We have KGA, thousands of years ago. And finally, MGA, millions of years ago. Okay. So yeah, that's it about the dates in the distant past. Now we go to the next part, next thing. Explanation of seriation. Okay. So seriation basically is measuring changes through time due to the changes in technology. Okay? Raw materials, all of that. And styles of artifacts. So, measure changes through time based on changes in technology or style of artifacts. Okay? What we mean by style is just that. We need to know that, of course, these type of things can be lost in time. Sometimes they appear first and then they get lost, so yeah. And we got with the self-dated objects. As we already said before, objects that has dates on them. objects with dates on them, or objects which reflect events of a known age. Age or date. The one that I explained before, it was for this or the other one. Good to know. Like basketball thing. And we also have to know that, as I mentioned, when someone died, they got souvenirs on their graves. So these type of things can be found here sometimes. But these souvenirs cannot date from a period earlier than that date. Earlier from that date. May be also dated by another generation. So possibly they cannot be sometimes that exact. And most of the time, all of them are restricted to no more than 12,000 years ago. Okay. Now, interesting thing, trees. So how we're going to study trees is through the dendrochronology. Okay. So for this, let's say we have something like this. Something like close or open. Maybe, I don't know. Like this over here. So let's say that this is a tree. This point in the middle, that's the first year of growth. Then we can identify by looking into the circles, like each one of them is 1 year, and 1 year, 1 year, 1 year. So trees, you can see that there are a lot of this type of things, like this circles. But you can identify when it was a rain season or a dry season, or even when, I don't know, forest. There was a forest fire, and you have a scar on the tree. So the way that we do this is by, when we get a rainy season, we are going to notice this. A lot of lines close together. So that's rainy season. When we have something like this, for example, like this, more open spaces between lines, we say that it's a dry season. And this little thing over here means scar. Or fire. What's yeah, like fire. So scar from forest fire. So just remember, start, rainy, thing over here, and dry. Okay? Perfect. Now we continue with radiocarbon dating. Okay. Now we continue with a moment with radiocarbon dating. Radiocarbon dating. Or C14. So for the radiocarbon dating, it's important to know that there are three different types of carbon: C12, C13, and C14. Okay? So we have carbon exists in three forms of isotopes. Which are carbon 12, carbon 13, and carbon 14. Now, carbon 12 and 13, they are both stable. 13 is stable, 12 is stable, 14 unstable. Okay? These are common. We have it everywhere. Rare and very rare. Okay? He's unstable and radioactive. Okay. Okay. Now, all forms of life contain carbon. Okay? So when we eat food, food that we eat also contains carbon. Okay? So how do we obtain this C14? Well, it's because C14 is actually C12, but because of solar radiation and everything, I don't remember exactly the explanation or something like that, it's transformed into C14. But C14, because it's unstable and radioactive, it starts to reduce. That's why we have C14 starts to reduce constantly, but at the same time that it's reducing, it's creating. So when we eat this food that contains carbon, we our own carbon 14 that it's lost is re-established again. Okay? By the food chain, of course. Okay? Okay, so yeah, the correct explanation of how this C14 is created is through action of cosmic radiation in the upper atmosphere. Okay? So as we explained here, every time an organism eats this, C14 is reloaded, like this, on the organism. But what happened when we die? Well, we stop eating. So that C14 stops being again reloaded and starts to decrease. Okay? And no new atoms of C14 enter to the body. So now we have this. As we were saying here, so we got stop having these new C14 atoms through the use of a special machine name mass spectrometer. Spectrometer. We can calculate how old something is. So let's say that, well, first we need to start with atoms of C14 have C14. Okay, so atoms of C14 have a life of 5,700 years. So, what this machine do is that we got a sample. Say a leaf. Breaks the atoms. Yep. And it says how many are in the leaf. Number. So based on a specific sample, and measuring the amount of a new leaf, in this case, we can say how many years this first thing is old. Okay. Of course, this is not precise. But still, looks something like this. Here will be the dates. Plus, minus, deviation of the VP. That's, for example, how old of this is obtained by the machine. Depending on the machine and its range and all, we can have this number. Mass spectrometer. Okay. Oh, so also, important to know, physicists can calculate range of time. That includes the date of death of an organism. Okay. So now we got the decimal doing dating. So how does it work? We got a volcano. Let's say something like this. Yeah. So inside the volcano, we have here lava, potassium, which is that radioactive solid. So when a volcano erupts, this with water or just freeze. Came into rock. It decays into argon-40. Okay. Yep. Now we have the OSL, or optical simulated luminescence. Okay. So I suppose it organic material or lava with the OSL. We date quartz crystals. That imported from near rocks. They absorb radiation. And to this process of absorbing radiation from surrounding rocks, we call it crystal lattice. Okay. So these quartz crystals are taken into a lab in which they're stimulated with light. For measuring the amount of radiation on the crystal. Okay. last time exposed to the sun. So normally, the data obtained by this is between a few 100 years ago to 100,000 years ago. Okay. Perfect. To the next part with the question of how. These people live. For technology, we have three different points. First one would be direct historical approach. Which assumes extends into past. We have the ethnographic analogy. Which basically is explaining that in a past generation they live in a certain similar way, with a similar lifestyle. And through experimentation too. The replication of the studies and raw material. Okay. then for analyzing the environment, we use, as we explained before, four different concepts, which are the chronology, rainfall patterns, such as those lines we can find on trees. And we have also the technique of oxygen isotopes, which help us to measure the temperature through time. We have the palynology, diet and vegetation, and funeral remains. For the local ecology. And our last two questions. First one, who? Where are these people? Okay. So, great context. Sex, age and death, pathologies, health, diets and disease. Diet determined by dentation. And also habitat behaviors. Okay. Some of the pathologies that can be found are osteoporosis, keloid breaks, hypoplasia. Arius lungs. And some most common known, such as cancer and syphilis. And the last question, why? They leave that way. Okay? So we don't have an answer for this question. It's just like the ultimate question. For anthropological studies. Okay? And that's all about week 4.